In this video, we will be making the geometry for our filament winding simulations for Ansys ACP, and for the composite part, the geometry will be consisting of the surface geometry, and for the mechanical parts like some sort of flanges or something, the geometry will be the metallic, could be stainless steel. So let's create the geometry in Autodesk Inventor file. You can create this geometry in any software if you like, if you have SolidWorks or CATIA or any software. Even you can make it in space claim. I mainly don't use space claims for my modeling purposes. I mainly prefer Autodesk Inventor. First thing we do, we will be creating a cylinder. The cylinder we will be using is being used for the storage of hydrogen in hydrogen fuel cell vehicles. So let's get started. Let's draw a circle having what should be the inner diameter. I make it 400. Okay. And as far as the wall thickness is concerned, I want to make it 6 mm wall thickness, and I want to make it for the length, I want to make it 1000 mm. 1000 mm was 1500, so that's it. It's not a solid. Okay, 1500 symmetric. Clicking OK. Now I will create its hemispherical ends. Slice graphics. Go to project geometry and select this and this line, this line and this line. Let's draw a circle and let's trim it off like this. And let's offset it by 6 mm like this. So we are good to go. Let's drop this like this and finish sketch. Now we are going to revolve it. You want to revolve this thing at this axis, and I want to make it 90 degree like this. Clicking OK. Now I will mirror it off using this plane. Clicking OK. I will mirror these parts by this plane. Clicking OK. That's it. It has been created. Now just make the holes for the flanges again. On this face, go to slice graphics, draw a circle of 25 mm, 3D model, go to extrude, symmetric, I wanna make it 2000, and I wanna cut this material. Okay, so my cylinder has been completed. Let's save it as, let's make it filament winding geometry. I have the cylinder here. Save. Now let's make the flame. Five mm, offset by 5 mm like this. 3D model, extrude. So make it 25 mm like this. Okay, now make on this surface and project geometry first, this face, and offset it by 5 mm, 3D model, extrude, and make it 10 mm like this. Okay, now let's draw a circle, holes for bolting, something like that. Pick the midpoint, 12 mm, 3D model, extrude it, whole face, invert, cut it, and now I will be patting this hole around it, circular pattern, this hole, and for the rotational axis I will be choosing this one. I want 4 holes That's it. That is the flange. So save it as a flange. Now create a new assembly file. Now let's place the cylinder first. I want to make it ground, and now I will be placing the flange straight, this one with this face, apply. Now I will be constraining this face with this face, so constrain, pick on this face and pick on this edge and make a distance of 200 maybe. Set, apply, OK. Let's import the next plane. Rotate Y like this. Now let's constrain this face with this part by 200. Apply, OK. So that's it. That was our geometry, a hydrogen cylinder. Now let's save it as assembly 1. Save. Now we will export it in CAD format. I want it to be in IGS format. Save. Now I will be extracting the surface files in SpaceClaim. I can do that here too, but mainly for extracting the surface file I use SpaceClaim. So let's open the SpaceClaim. So this is our SpaceClaim. Let's import our model. Go to all files. Here is the assembly IGS. Now what I will make, I want to make the surface file of all these bodies. I will select outer surfaces like this. I will simply Control C and Control V here, and you can see a surface has been generated. If I disable all other bodies, you can see this is the surface that has been generated. Now let's save this surface in the form of parasolid. This one, surface file. Now just enable flanges and turn it off everything. Now we will be suppressing all the other bodies except the flanges like this. Now we will be saving again. Save as IGS file. Flanges. Save. By doing so, we don't need to assemble our cylinder and flanges in our workbench systems or in workbench environment. So it will save our time. Now let's open the Ansys workbench in the next videos. Now the geometries has been created in this video. Thank you.